Hello and welcome back to Calculus 1, section 3.4 on product and quotient rules. We learned earlier that, let's go purple, that the derivative of sum or difference is the derivatives, the sum and difference of derivatives. This does not work for multiplication. There is a special formula for multiplication. So you cannot take independent derivatives and then multiply answers. That will give you the wrong answer 100% of the time. So the formula that you have for addition and subtraction works differently than formula for multiplication and division. So what is our product rule? Product rule says this: the derivative of f times g is the derivative of f times the derivative of g, there we go, plus g times the derivative of f. This is the product rule formula. Yes. Nice. So note that it's more complicated than you would think. It's not a product of derivatives. It is the copy the first function times derivative of the second plus copy the second derivative of the first. Some people like to write this formula with u and v being the functions. So they just say uv derivative is uv prime plus vu prime. You will see this as well. U is equal to u of x. You can think of it as f of x. And v as v of x. You can think of that as g of x. So whether you're going to learn this as f and g or u and v, I don't care. It's just all the same. Some people like the u and v notation for this better. As you go through literature, you're going to find one or the other, right? That's all. So now we do some examples. What is the derivative of x squared times x to the 10? Well, following the formula, x squared would be f and this would be g, or you can call them uv, whatever. So copy the first, that's x squared, times derivative of the second, which is 10x to the 9, plus copy the second times derivative of the first, which is 10x to the 11 plus 2x to the 11. When you multiply these x's, you add their exponents, right? For a total of 12 x to 11. Let's check. What else can we do with this problem? What else can we do? Instead of running the big formula for product rule, can we do something else? Yeah.
Just multiply.
Just multiply to make a basic problem, right? So you start from there, make this x to the 12, and then use just basic in derivatives, and there it is. At which point you go, wait, why do we need the product rule for if I can do this, right? Well, you can't do it all the time. You can do it when you have two polynomials. Try it now. Right? Now you can't multiply first. So obviously on the problem up there, the first example we did, you should go the green route, right? Because why use sledgehammer if the normal one, regular size, would do it, right? But for the one on the bottom, right, the new example, you can't multiply x cubed with e to the 4x. So you are stuck, and you have to use product rule. And the product rule, again, we have our f, we have our g, or u and v, whatever you like. And just multiply. Copy the first times the derivative of the second, 4e to the 4x, plus copy the second, e to the 4x, times derivative of the first, which is 3x squared. So now in your formula is your fg prime plus gf prime. So that's the way it goes. And now we need to simplify this. So the first one is 4x cubed e to the 4x, and the second one is 3x squared e to the 4x. So as much as you would love to end here, no. We factor this. There we go. Yeah. So we factor this. And you would ask why? And I would say because next chapter. In the next chapter, you doing this is a first step of a 13-step problem. So you would have to equal this to 0, solve the equation, and then go on with the problem. If you equal it to 0 here, you can solve. But if you factor, then you have multiple factors, and each individual factor equal to 0 is a joke to solve. So you have to practice skill of factoring your answers now, so it becomes a second nature, so that when chapter 4 rolls along, you can just continue from that point on. So now I get to factor x squared e to the 4x from the first one, 4x, from the second one, the 3. So now look what happens here. Just get my trusty pointer. There we go. You have, if you have to equal this to 0, you have x squared equal to 0. That produces two answers, which are both 0, so x equals 0. Then you have e to the 4x equals 0, which has no solution. And 4x plus 3 equal to 0, which has negative 3/4 as a solution. So it's a joke to solve this equation. You solve it mentally if it's factored, because you know that each factor individually gets equal to 0, right? It's called zero product rule from algebra. You learned that. Here, there is nothing you can do. You can just stare at it. Even if you try writing stuff, you can't solve it from this form. So the goal for this section is for you to learn not just the formula for product rule, but also to get this factoring down to the point that anytime when you can factor something, you factor it quickly, and you go from there. Let's go and do some examples from the book. So these are my two introductory examples. The top one, again, if you can use algebra to make life easy and skip the long product rule formula, do it, right? Do it. But if you run into the situation down below, you will have to use product rule. All right, so here are some examples from the textbook. We'll start with the warm-up example 23. It says the derivative in respect to t of t to the 5/3 times e to the t. So clearly here's your f, here's your g, go. Okay, let's take a look at this one. So copy the first, which is t to the 5/3. Then derivative of the second, well, derivative of e to dx is e to dx, derivative of e to the t is e to the t. Plus copy the second, which is e to the t. And now derivative of the first, we drop the exponent down, so that's 5/3 t, and then minus 1, so 2/3, right? No. Oh, yeah, but... Yes. Okay. Yeah. So now, we'll go here. Factor out t to the 2/3 e to the t. What's left in the first one is t, and what's left in the second one is 5/3. And we're done. All right, problem 33. The derivative in respect to w of e to the w times w cubed minus 1. The same, right? More of the same. Copy the first, derivative of the second. Bye, see you next week. Plus this times derivative of the first, which is the same. So now EW, and we are left with W cubed plus 3W squared minus 1. Correct? 32. The derivative in respect to x. Finally, our beloved x. Right? 1 plus 1 over x squared. X squared plus 1. Here's your f. Here's your g. So the only issue here, right, is this 1 over x squared. So we learn to write that one as x to the minus 2 so that we can run our calculations quickly. So copy the first one. That's going to be 1 plus 1 over x squared times the derivative of the second, which is 2x, right? Plus copy the second, which is x squared plus 1, times derivative of the first, and this is why we had to do this, so it's negative 2x to the negative 3, because we subtract 1, right? And now, when you multiply 2x, you get 2x plus 2 over x, because x is cancelled, plus, now this one over here is negative 2 over x cubed, and that distributes, so this is not plus, it's a minus. So minus 2 over x, right? And minus 2 over x cubed. Now these guys drop, and you get 2x minus 2 over x cubed. So I hope you would agree that this problem is a living nightmare, right? And you know what? It's okay to be a living nightmare because this is the wrong way to do this problem. They do ask you to use product rule, right? And as you can see, you can. It's just, I mean, it's not hard, it's annoying. There's a difference between, right, problems that are hard and problems that are annoying. This is an example of annoying problem. I'm going to ask you to use algebra, which means multiply first, FOIL, there we go, and do this problem the other way. Remember, you have to get that same answer at the end. So when we FOIL, we get x squared times 1 is x squared. And then x squared times 1 over x squared is 1. And then 1 times 1 is 1. And plus 1 over x squared. 1 plus 1 is 2. But when you take the derivative, that will go away. Because they're constants. There's no more product rule. FOILing eliminated product rule. So we can just take these derivatives quickly. The derivative of x squared is 2x. And the derivative of the other one is negative 2 over x cubed. So again, don't use, 30-pound sledgehammer if a 5-pound framing hammer will do. Right? That's our product rule. Second part of this lecture is quotient rule. For the quotient rule, we have f of x divided by g of x. And now this is the formula, as you mentioned, division and subtraction. That's great. So we have g prime of x times f of x minus f prime of x, g of x divided by g squared. So the derivative of 3x squared minus 1 divided by 4x plus 3 is, I always take denominator first because all you get to do is to copy it and square it. I like to start from the denominator. And then it's the denominator is the first thing that you put on top. Because, oh, I got my primes over here backwards. Guys, formula, fix it. Ow, 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 ow. What is this? Fix the formula. I put the primes on the wrong spot. So you technically copy g twice and then you do the rest of the formula. So you put 4x plus 3 and you square it in the denominator, then you put 4x plus 3 on top times the derivative, which is 6x, minus, now copy the top, which is 3x squared, minus 1 times the derivative of the bottom is 4. Did you all fix the formula? Is gf prime. (24x squared plus 18x minus 12x squared plus 4). Remember, there is a minus here and a minus here, so it's two minus signs. That's a plus. 4x plus 3 squared. So now we have 12x squared plus 18x plus 4 divided by 4x plus 3 squared. You could factor 2 in the numerator, but it doesn't really eliminate your coefficients anywhere. It doesn't cancel with the denominator. It's beneficial to cancel 2 because if you have to do quadratic formula to set numerator equal to 0 and do a quadratic formula, it's much better to plug in a quadratic formula 6 and 2, sorry, 6 and 9 and 2, than 12, 18, and 4. So, for purposes of this particular chapter, factoring 2 is not so important, but it's a lot important for chapter 4. So I am going to box this answer, and I'm still going to write the other one because I know what's coming up in chapter 4. So 2 times 6x squared plus 9x plus 2 divided by 4x plus 3 squared. And I'll just say chapter 4 is coming. You know, it's like winter is coming. Well, chapter 4 is coming, right? Both of these answers on the chapter 3 test would be 100%, right? It's just that the chapter 4 test, right, would be much faster. Another thing, denominator, you do not have to square denominator ever for few reasons. Reason number 1, we just don't want to. Reason number 2, anytime you set this equal to 0 in chapter 4, that 0 will always kill denominator. So why would you cross multiply? So denominator never plays a role in solution. So we don't care, right? So why do any extra work if you're not going to use it? Now that denominator does tell you that there is a vertical asymptote at -3/4. So you can't ignore it. You can't just go and say, I don't care about denominator ever because it's not going to give me any solutions for whatever I am talking about in chapter 4. It will give you a vertical asymptote, so you can't throw it away. But you don't have to work hard on it in terms of foiling and squaring, computing, and doing all these things because it doesn't come up in calculations. So just leave it as squared 100% of the time, right? It's already in the best factored form. You foiling that will just make a polynomial, then, right? What you can't see asymptote anymore, right? Once you foil it out. So just leave it there as squared. Always leave it as squared. And numerator, always factor. But as I said, right now, for chapter 3 answer, we don't gain much by factoring 2. If you had to factor x as well and stuff, yeah. But, you know, factoring only 2 for chapter 3, not a big deal. Big deal for chapter 4, though. So do it. Let's see some book examples on homework. Here is their idea of fun. Starting with problem 25, with the derivative of e to the x over e to the x plus 1. Go. All right, so we start by squaring the denominator. Then copy the denominator. Then derivative of the numerator, which is e to the x, minus, then we there we go. Oh, come on. There we go. So copy the denominator, derivative of the numerator, copy the numerator, derivative of the denominator. There we go. So now, FOIL, I'll distribute. So it's e to the 2x plus e to the x minus e to the 2x. E to the x plus 1 squared is to drop. And what's so cool about the answer? It's very close to the original problem, right? It's just denominator is squared. It's almost the same. Let's take a look at another example from the textbook. Shiny. 49. dw of square root of w plus w divided by square root of w minus w. Have fun. All right, let's see. So we have square root of w minus w squared, square root of w minus w, times the derivative of the top. The derivative is 1 over 2 root w plus 1. You might want to memorize that the derivative of square root of x is 1 over 2 root x, because you will see this 5,000 times in your calculus and differential equation life. This is not a major formula, because you write x as x to the 1/2 and then you just use the x to the n. But the square root of x is so frequent that writing it every time as x to the 1/2 and running the calculation aside becomes annoying. So you might want to memorize this as a formula and just use it every time you need it. It's very quick. Square root of x is 1 over 2 root x. You start with root x, you have root x in the answer, so it's fairly simple to remember. And you see also the half, right, from the exponent, so it's all good. So you saw me use it here without explaining that the derivative of square root of w is 1 over 2 root w. And then the derivative of w is 1. Minus copy the top, square root of w plus w, times derivative of the bottom, which is 1 over 2 root w, minus 1. Now we FOIL. When I multiply the first, root w cancels, so I just get 1/2. Minus w and root w, so it's just root w over 2. Plus root w minus w. And now the second one, you have to be careful with the minus in front. So we have another minus 1/2. We have root w minus root w over 2. We have plus root w because you have a negative 1 and then negative root w. And you have plus w at the end. Divided by root w minus w squared. 1/2 and the negative 1/2 are gone. Negative w and positive w are gone. I have 2 root w minus root w, because when you combine these two, it's like saying negative 1/2 minus 1/2. Well, that's negative 1. So those two combine, and then I have root w minus w squared in denominator. So it's root w divided by square root w minus w squared. Now there's really no way to check this other than to use technology. So you can go to Wolfram Alpha or whatever. If you install Mathematica on your computer, you have very powerful tool. And you type in, you just talk to it. Derivative of, and you type the problem. So we have w raised to the 0.5. That's w raised to 1/2, which is square root of w. Plus w divided by w raised to 0.5 minus w. And you hit enter. It will show the problem first. There you go. Ah, great. I typed X instead of W. There we go. I think they have factored form here. I'm trying to figure out if the answers are the same. So we'll have to do some algebra just to see if the answers are the same. So they say that the answer is 1 over square root of w minus 1 squared square root of w. To check if these are the same, I will multiply it by root w, like this. I will multiply by root w because I need root w on top. So that's root w on top, and now on the bottom I have root w minus 1 squared times w. And now this needs to go in, and we have root w on top. When this goes in, it picks up the square. I don't like it. Root w plus w, root w. Okay, so let's see. The software tells me that this is wrong because I'm not getting the same answer. I am getting w to 5/2 minus w squared, everything squared. That's what I... Right? So let's see if our calculation went well. Copy denominator, square it. Copy denominator. The derivative of top is 1 over 2 root w plus 1 minus, copy the top, derivative of the bottom. Good. FOIL. Root w's would cancel. I just have 1/2. And then it will be a negative root w over 2. Good. Plus root w minus w. Good. One half negative root w over 2 negative. Okay. Negative positive root w, positive root w, and positive w. W's cancel, halves canceled, minus root w, and plus 2 root w. Alright, well, this looks good. I'm not sure why it's not matching the software thing. I have no clue. I love this stuff. I'm going to try now Symbolab, see if we get the same. It's just really interesting that it didn't work. Alright, it just gives me the same. Now I'm bothered why Wolfram is not giving the same. They have the x's, it's the same thing. Here's your root x over the same answer we have. So Symbolab does give us the same answer. I'll have to meditate more on this Wolfram answer and see why, but Symbolab confirmed what we have, so eventually I'll take a look at this. Next problem. I saw it somewhere. There it is. 48. The derivative in respect to x of, lock the doors, x plus 1 over x squared e to the x. Whew, spicy. What is tricky about this problem? You have to do the product rule inside a quotient rule. Yes. Go. Yep. This is a evil, evil problem. Let's take a look at this problem together. All right, so we have to start a new line because right, it's going to be like that. We have x squared e to the x everything squared in denominator. Numerator, x squared e to the x copy times derivative of the top, which is 1, minus. And now you have to do copy the top, x plus 1, and then derivative of the bottom. Derivative of the bottom is a product rule because you have x squared times e to the x. So this problem is product within quotient. Problem is product within the quotient. So product rule for the bottom, I'll do that, let's say green. Copy the first, derivative of the second, plus copy the second times derivative of the first. So there's your product rule. Which is there. So now we FOIL, it's x squared e to the x minus, and now there's a lot of stuff that we have to do here. What happened? We have x times each one of these. So we have x cubed e to the x minus 2x squared e to the x minus x squared e to the x minus 2x e to the x. X squared e x squared. Simplifying these things is more work. So now these cancel, right? And the rest can kick out e to the... Why did I erase this line? Kick out x e to the x. We can kick that out. And the negative as well. From the first one we have x squared. From the second one I have 2x. And from the third one I have 2. Now, denominator is x squared e to the x times x squared e to the x. And the reason why I separated that is now I can cancel this, and x with a square, which now leaves the problem as negative x squared plus 2x plus 2 divided by x cubed e to the x. Woo! Awesome, right? This is called mathematical gymnastics. All right? Absolutely no reason for it. We can do it. So let's do it. All right, one more problem and the lesson is over. These are just examples. So now we know that we can have product inside the quotient and quotient inside the product. They can be combined in that way. So 54. Find the derivative with respect to z. Cross your z's so you are not confusing them with 2's. of z squared plus 1 divided by z times e to the z. So what kind of problem is this? The nightmare, exactly. So it's quotient inside the product. The product is the main because this would be your f and this would be your g. So you have f times g as the big problem. Now, within this big problem, you can use u and v. You have u divided by v. So this is quotient within the product. So product is the main, and then the quotient will fit whenever we have to do it, right? So let's go. Copy the first times derivative of the second. Well, that stays the same. Plus copy the second times derivative of the first, and this is where the quotient rule kicks in. We get z squared down there. We got z times the derivative of the top, which is 2z, minus copy the top, z squared plus 1 times the derivative of the bottom is 1. Right, so now we simplify this. I am going to keep this first one still the same, and the second one starts also with e to the z, because I need to fix this. I have 2z squared minus z squared minus 1 over z squared. So this over here is z squared minus 1. Now, I can multiply the first one by z, top and bottom, to get z squared common denominator. And then I can factor e to the z over z squared. And now I have z cubed plus z, and contribution from the second one is plus z squared minus 1. And all I really need to do here is to put in descending order. So I'll just say this is a square and this is a z, and there you go, done. So there we have it. Now you get to set them equal to 0, each one of them, when you are in chapter 4, and get to critical points, mean, max, and first derivative test, increase, decrease, intervals. That's chapter 4. Right. That's it. That's the product and quotient rules. You must memorize those formulas. And then if you run into the annoying problems, you will have to recognize which one is the main and which one is inside, and then just work your way around it. Bye.